In this video, I'm going to be covering question 6, part D of the 2022 AP Calculus AB free response no calculator allowed section. So I cover A, B, and C in previous videos, so if you want to see those solutions, feel free to go back and watch those videos as well. They're pretty good. Part D here wants us to say what happens as t approaches infinity. Which of the particles that we're talking about, whether it's particle P or particle Q, will eventually be farther from the origin. So to do that, what we're going to need to do is take a limit as t approaches infinity for our two position equations. We had one position equation given to us for x here. So we can set that up. That would be limit as t approaches infinity of 6 minus 4e to the negative t. And then on question C, we found the position equation for particle Q. And for that one, we found out our final solution on that. Again, you can go back and watch that video if you want, was negative 1 over t plus 3. That was our position equation for Q. And so here we also need to find what is the limit as t approaches infinity of negative 1 over t plus 3. When you're doing limits at infinity, there's really just three options on how these problems can ever work out. And once you know that, it becomes real quick and easy to find the solution. So I refer to them as first option would be top heavy. What we're looking for in these situations is what I call the dominant term, the term that's going to dominate how this graph behaves over the long haul. So usually that's the highest power of x, but it can also be an exponential function is oftentimes the dominant term. You have to look at it and see. But when I go through, option one is the top heavy. And I would say what that means to me is as I take my limit here, the dominant term shows up only on top. So maybe that's like 7 times x to the fifth plus 3x to the fourth over 9x to the third plus 8x. In this situation, the dominant term is only on top here. And so what that means is the top of this fraction is growing out of control, and there's really nothing the bottom can do to stop it. And so what you get out of here is the answer is that this graph, this equation would be headed to infinity as x goes to infinity. So heading to infinity would be your solution here always if you're in a top-heavy scenario. Then option two is the flipped version of this. That's what I refer to as bottom heavy. So in that situation, the dominant term is only on the bottom of the fraction. So kind of flip what we just were looking at on that last example. So 9x to the third, and then on the bottom we've got 7x to the fifth plus 3x to the fourth. So here in this situation, the dominant term, that x to the fifth, is only happening on the bottom here. And so what that means is we really have sort of the flipped version of that other fraction. So the top isn't getting very big compared to the bottom, which is getting huge. And so what's happening here is 1 divided by infinity is like a decimal point with a whole bunch of zeros, right? Which is essentially saying 0. So when you are in a bottom heavy situation, that is always going to head down to 0 for your answer. And then option 3 on this is just what I would refer to as balanced. You have equal dominant terms on top and bottom. So we would have limit as x approaches infinity, and we'll call this 9x to the fifth plus 8x over 7x to the fifth plus 3x to the fourth. So in this scenario, we have equal dominant terms on top and bottom. So the top and the bottom of your fraction are growing at the same pace. The only difference becomes the numbers in front. So the top one is always going to get multiplied by a 9. The bottom one's always going to get multiplied by a 7. And so that would be our answer here. And so on balanced situations, it's the coefficients of those dominant terms that ends up being your answer always. So those are the only three ways that these limits at infinity can happen for us. And so what we want to do is go back and apply these three ideas to our two problems and see what's going on there. As you look at the first one, anytime you've got negative exponents on a problem and you're trying to do some algebra work, you're trying to figure out what's going on, you really want to undo that. That's a rewrite that you normally want to make it a negative exponent. You normally bring something up from the bottom to the top and make that power negative. So if you had like 5 over x to the third, you would rewrite that as 5x to the negative 3. When we're going to do some real algebra on it though, what you want to do is kind of undo that rewrite. Bring that negative exponent back down to the bottom. So if I undo my rewrite here on this one, I would get limit as t approaches infinity of 6 minus, the 4 stays up on top, but now my e to the negative t goes to the bottom, so e squared, or e to the t, excuse me. So what I can see happening now that I've got that as a fraction, I can see that my dominant term on this is going to be down here, that e to the t. E to the x, e to the t graphs, they're always heading to infinity. They're always getting bigger and bigger. So that is my dominant term here. So for this portion of it, this would be a bottom-heavy scenario. And so that bottom-heavy scenario, that whole thing is headed to 0. So what I really have is 6 minus 0, because the constant doesn't go anywhere. And the answer to that is going to be 6. So as t heads to infinity, I can see that my x particle here is going to be headed to 6. Then going and looking at my y particle, I see again, I'm in a bottom heavy scenario on the front chunk here. So the t on bottom, that's my dominant term. So this is again another bottom heavy scenario. So again, we're looking at option 2, which shows me that this first piece here is going to head to 0. And so now what I'm looking at is 0. The constant stays around. There's no t with it. So then 0 plus 3, that is going to equal 3. And that's where my y particle is going to end up. Well, now you have everything you need to know what your answer is. You know that the x particle is going to be at 6 over the long haul as t goes to infinity, and the y particle is going to be at 3 as it heads to infinity. So you know that 6 is greater than 3, so the x particle will be farther from the origin. And that's it. When you do limits at infinity, it really boils down again to these 3 options right here. And if you know what those 3 options are, it's very quick and easy to find a limit as it goes to infinity. And so on this problem, this one would have been worth 2 points. You've gotten 1 point for just kind of setting up the proper limits up top here. And then you would have gotten 1 point for showing them that you understood that 6 is bigger than 3, which hopefully you know in a calculus class. And that tells you that the x particle would be farther from the origin. That would have been your 2nd point. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.